Hi, in this video, I'll explain what is terminal velocity of an object under free fall. What do we mean by an object under free fall? Let's see. Let's say a person is standing at the top of a very tall cliff and he drops an object from here and it starts moving downward with acceleration due to gravity, which is g. And if we consider the upward direction as positive, then this can be negative g. So that's just a convention. So it moves at roughly 9.8 or 10 meter per second square acceleration, which means every second 10 meter per second approximately per second is getting added to the velocity, right? Velocity is initially 0, then after 1 second it becomes roughly 10 meter per second, then 20 meter per second, and so on. So let's try and understand this through some plots. If we plot acceleration versus time for this object, then we know that acceleration is constant, which is 9.8 meter per second square. The same for velocity versus time. Initial 1 second, it will be 9.8, then it will become 19.6 in the next second. The third second, it will become 29.4 meter per second, and so on. Roughly, we can say it increases from 10 meter per second to 20 meter per second to 30 meter per second in 3 seconds. And we know that for uniform acceleration, the plot of velocity versus time is a straight line with a slope as seen here. What about displacement versus time? Since every second the velocity is increasing, every second the displacement will also increase. That means the first second, how much ever it is being displaced, let's say in this case it will be 5 meters. We can also use S equals ut plus half at square, to verify this. If we take the initial velocity as 0 and a to be roughly 10 and time interval as 1 second, we will get 5 meters. But then the velocity at this point would be 10 meters per second. It would have displaced itself 5 meters. Then the next second, it will displace itself more than 5 meters. It will typically be 15 meters. So it will be at 20 meters distance from the origin, displacement from the origin. The next, it will displace itself probably 25 meters. So it will be at 45 meters from the origin. So this is how it exponentially increases. It's not a straight line because every second the displacement is more because velocity is increasing every second as seen here. So this is how the displacement versus time plot looks like.